Back again to another video. Last video we worked on infrastructure security. In this video, we're going to do access, identity and access management. So first, we're going to go over enabling multi-factor authentication. So single factor, right, or single factor authentication just relies on a username and password to protect the data, right? While multi-factor authentication relies on more than just one form of verifying the user that's being logged in. So for instance, whenever you've logged in and it'll say, oh, even though your password and your username are right, we're going to send you an extra layer of security as far as sending you an email or text message to, whatever is on file with your account to verify that this is you logging in. They'll either send you your code or a link or some variation of that in order to make sure that you're able to access your account securely while inside, right? So first, what we're going to do to take a look at this is enable the smart card log on. So logging using a smart card, logging on typically calls for third-party software to be installed on the client and servers. Also, management tools are required to administer the creation of like revocation of the smart card to corporate users, right? So there's no physical smart card is what I'm trying to say installed on our platform, on our lab here. So we're just gonna take a few steps just to show how to enable the smart card logon. So let's take a look at Active Directory users through Server Manager here. So let's see, using the computers, right? And let's see here. Click on here, right? And let's see Matthew. Let's take a look at Matthew. Properties, right? And let's take a look at the Account tab. Card required for interactive logon. All right, perfect. And then okay. All right, perfect. So I'm just gonna close this out. Right. So now I'm just gonna verify the capability of it, right? So when you configure your user to log on this way, they must use it again on the next login. So without a smart card, the user just won't be able to proceed any further beyond the login screen, right? So just gonna sign in as the domain user to kind of like test the smart card capability out. All right, so let's make sure that the feature for auto login is disabled, which I'm doing now. And then I'm going to connect. I'm going to swivel over to this particular device. Let's see. Actually, because I already had it running. I'm actually just going to sign out. I already had it up and running previously just to make sure everything was ready to go. But I'm signing out now. And I'm just going to sign in as another user. Let's see. Come on. I shouldn't be doing this. That. All right. So instead of using the server I wanted to use, I'm just going to use the current server that we're on. So let's try to log in as Matthew, right? I'm not sure if he's a bear or not, but let's see. There it is. You must use a Windows Hello or smart card to log in. Now, since the user was configured for a smart card login, this system message appears, right? So if a smart card has been assigned, we'd be able to proceed. We'll be able to proceed past this point, of course, and log on as normal. So we can actually, now that we've configured that, and then we can actually move on to our next exercise here. All right, so for this activity or exercise rather, we're going to configure mandatory access control. So in Linux, when you would use standard permissions, right, such as like RWX read, write, execute, right? So an access control list, ACL, there is another method, right, of enforcing strict permissions. So this method is known as the mandatory access control. So which is used as the, let's say, SE-Linux for security enhanced Linux, right? So it's enabled by default on this particular server that we are on with Practice Lab Alma. And this default mode is enforcing, and SE-Linux should be kept, of course, in this mode as a recommended practice. So what we're going to do is to view the current status of the SE-Linux. So to do that, let's actually open this up here. Open up a terminal. All right. If you, uh, there we go. So now we're at the root, which is great. So let's clear this out, and then we want to get enforced. Right? Perfect. Enforcing. All right, great. So now that's the current status, right? It's enforcing, right? So now we want to get an overview of the SE Linux configuration. So take a look at the status, or at least that's the command. There it is. All right, perfect. Current status enabled, amount, system, SE Linux, targeted, enforcing, and enabled, allowed, blah, 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 right? So now we see the overview of the configuration for SE Linux. So we're actually going to clear this out since everything looks pretty good. So I can spell, right? I should create a compilation of all the time on these videos of spelling. All right, so let's go to config. All right, perfect. That was pretty quick. I love it. All right, so now the overview of the SE Linux configuration is now displayed, right? So now we're going to actually change the SE Linux mode. So let's clear this out again. Then we're going to set enforce 0. Now it's going to change the mode to permissive, right? For the set enforce. So no responses is returned, which is okay. That's fine. But we can verify the change mode, right, with the SE status that we did before. So let's do that there. All right. So enabled, allowed, actual, secure. All right, perfect. So now the mode is now changed, right? Because we see it in this permissive state in the current mode, right? So this is only a temporary change, right, until the time the system reboots. And after the system reboots, then it's going to be in another mode that will be used, right? So to make the change permanent, we're gonna have to change it, a couple different ways. We can do that. So let's actually change the mode here. Force, right? Permissive. So, well, we just verified it rather instead of changing it. It was already safe. So it's permissive. Now, again, it's only a temporary change until the time of the system reboot. So let's actually clear this out. So we're going to change the mode of enforcing that we'll use again. The set enforce command, we're going to do this instead. All right, set enforce 1. So now there's no output once again, but we can still verify that the mode changed, right? So get enforce. All right, and forcing. All right, first it's not permissive anymore, it's forcing. It's enforcing, so the mode has changed and we've successfully seen the status. So now we're going to view SE Linux, the context for processes, domain transitions, and users. So each process is marked with the SE Linux context, right, which contains additional information like user, role, level, type, and things of that nature. So we're actually it's used for making access control decisions, right, which is rightfully so. So we're going to view actually the context for these things, right? So we're going to fill this out, and we're going to do a familiar command we've done in other videos. So now we created a new file named plab.txt, which is a text file, right? So now we're going to view the security context for that text file. So we're going to do ls and then z, capital Z, right? Then the text file, right? Unconfined you. Let's see. The admin home. All right, so the output, it just displays the user role type level information, right? So we can actually clear this out. And then we're going to view a list of mappings, right, between a Linux and the Linux user account. So let's see, nod, right, seminod. All right, perfect. So now we see the output of the seminod command, right, that's displayed right here. So each application in Linux usually has like an entry point permission, right? So which is used by the SE Linux policy. So the entry point permission, it controls which applications, right, can be used to enter a domain. So we're actually going to let's take a look at something like that of that ilk. So let's see, USR, then it's here, right? See, make sure I spelled it right. All right, perfect. So, and I want to make sure that the D was capitalized, otherwise the command would have failed. But now we notice the label, the password underscore execute right here, underscore T, right? So now that we notice that, right? So let me actually clear this out again. So I want to test that out. I'm going to view the SE Linux context for the processes that are running on the system. So now we can change the password. I'm not going to enter anything. I'm just going to keep the terminal window open. Now I'm going to open up a new one. Actually, new window. And then, okay. Then we need our pipe. Then we need to be more concise. The grep. All right, prep. Perfect. Perfect. All right. So just going to go back here and then do that here. Let me make sure it's clicked. There it is. All right, perfect. So just going to go back here now, and then I'm going to type. All right, perfect. So now see the SE Linux context for the running processes, right? So I'm just going to clear it out, and then ID, make sure it's a capital Z, right? So now in this server, right, users are marked with an unconfined U, right? So they also run, as you can see here, and they also run with the unconfined R role, right? So the output of this command is just displays this, right? And it shows the user is then running with the unconfirmed T domain, right? So that'll bring us to the end of this video for identity and access management. Thank you so much for still being here. Well, we've done a few things. We enabled multi-factor authentication with the smart card login. We also performed a configure mandatory access control. I could go a little bit more depth, maybe in another video for performing manual review and privilege management. But what we did actively today, we enabled the smart card logon. We viewed the carrier status of SE Linux. We also viewed the SE Linux context for processes, domain transitions, and users. So in our next video, we're actually going to get into infrastructure solutions, and I'll see you there.